Hota family, welcome to mathematics lesson number 1, Di Ankh Mira. We are often confused by the English language because it has no mother tongue or father tongue for that matter. It is designed to be confusing. English may best be characterized as the primary language of people who speak with forked tongues or the language of liars. The primary objective of these units is to be able to do calculations using the sacred script of our African ancestors, Medu Neter. We are all students and teachers. Subscribe. In all languages, it is important to be able to identify truth. Mathematics is the language of truth. In Medu Neter, we call that process finding the beauty, or Gem Mek Nefer. In the area of mathematics called arithmetic, we say we are calculating or doing calculations or calculus. Calculations use numerals, that is to say, signs or symbols to represent specific values. Many, if not all, cultures have words to represent quantities or numbers. Here are some examples. We have 5 examples of an African language, 3 of what's considered a Romance language, 2 European, German and Irish, 3 other Europeans, which are Greek, Bulgarian, and Russian, and then we have Hawaiian and Arabic. There are many different ways to say the same numerical value as there are languages. All of these languages are referring to the same quantity. In English, that quantity is spelled F-I-V-E and pronounced 5. Those letters are considered to be of the Roman alphabet. If we look at the name of the word 5, we see that it really doesn't seem to have much of a connection with any of the other groups of languages. So in addition to words to represent numbers, we have various symbols. These symbols we call numerals, and the lessons in mathematics will focus on the Medu Neter numerals, but on this screen we can see that we have Greek, Chinese, Roman, Babylonian, and Egyptian numerals. These 5 numerals are accurate representations or true representations of the quantity of stars at the bottom of the screen. It would be fair to say that these numerical symbols are written from the oldest numerical symbol on the left, Medu Neter, to the newest numerical symbol on the far right, which is Hindu Arabic. They are all ways of representing the quantity 5. At the top left-hand corner, we see what's called the Shango bone. I will call it the Shango calculator. It was found in the Democratic Republic of the Congo. It is thought to be at least 20,000 years old. Next, we have Greek, which is about 3,500 years old. Roman numerals, which are about 2,700 years old. The Arabic numerals are about 2,500 years old. And the Hindu Arabic numerals, which took form in Europe in about the 1400s of the Common Era, are only about 600 years old. The Ishango calculator, however, is not the oldest numerical instrument that we find in Africa. There is the Lubumbo bone, or Lubumbo calculator, and it is considered to be twice as old as the Shango calculator, meaning that it would be about 40,000 years old, and it was found just north of South Africa. The numerical system used by our African ancestors is a base 10 system. This can be seen in the Medu Neter and in the Hindu Arabic numerals that we are taught in school. By base 10, we mean that we have a base value of 10, and there is an exponent telling us how many groups of 10 there are. Our focus will be on these numerical values. It is believed that the base 10 system is used by humans because of the 10 fingers on our hands. The base 10 system has, again, a 10, which tells us how many groups of 10, and an exponent to tell us how many factors of 10 there are. So in units, we have no groups of 10, and therefore the exponent is 0, telling us that that is the number 1. 10 to the first power means that we have one factor of 10, and we have 1 10 or just 10, 10 to the first power. 10 to the second power means that we have two factors of 10, or 10 groups of 10, or 10 times 10, which would give us 100. The exponent 2 also would indicate that there are two zeros when we write the number in standard form. 10 to the third power tells us that we have three factors of 10, which is 10 times 10 times 10, which if we carry out that multiplication, it gives us 1,000. Again, the 3 tells us that there will be three zeros in 10 to the third power. So continuing the process, next we get 10 to the fourth power, which is 10 times 10 times 10 times 10, which would give us 10,000. And I'm sure you can guess how many zeros there would be based on the exponent. When we have 10 to the fifth power, that's again an indication that we have five factors of 10, which would give us 10 times 10 times 10 times 10 times 10, or 100,000, or 1 with 5 zeros. And the largest Medu Neter symbol for a base 10 number would be the 10 to the sixth power, which is the seated Neter with its arms raised, which represents 10 to the sixth power, or 1 million. So the other name for the base 10 numerical system is the decimal system, because it's decimal meaning base 10. And when numbers are written in standard form, we can place a decimal point following the last digit of any whole numeral. The decimal is usually omitted, but I put it in just for emphasis. It must also be indicated that this is a place value system. Our system depends on the place of the digit to tell us the value of that. So each red one is in its proper place. So the 1 in thousands place is to the left of three zeros, telling us that is the thousands place, and so on. So now I'd like to take a closer look at the Medu Neter symbols, which is the symbols that we will focus on in all of the following lessons. So in Medu Neter, the unit, or 1, is represented by tally marks, just like those on the Shango calculator. In Medu Neter, the numeral 10 is represented by what I believe is a door handle. This was the only representation of something that looked close to the Medu Neter symbol for 10. In Medu Neter, the symbol for 100 is represented by a coiled rope. For 1,000, our ancestors used a lotus flower. The number 10,000 is usually identified as a pointed finger. I guess that's possible. I I'm going to use a boomerang for now. I may change that at some point if I'm convinced that that is a pointed finger. I haven't seen anything to confirm it either way. 100,000 in Metal Nature is represented by a tadpole, which kind of makes sense. Usually they come in large numbers. The nature hehe or aha symbolizes the concept of 1 million. Also, hehe is identified as a symbol for infinity or eternity. Earlier in 2023, I did a lesson, lesson number 5, where I shared the below information or the above information and more information on the applications of the numerical system. So here's a clear example of the Meta-Netia numerical system, where we see the symbol for 3,333,330 represented on, that's a column, I'm sure. I also wrote it in what's considered expanded notation, where we see each three in a place. So the three in the millions place, three in 100,000 place, and so on. If you add that all together, you get 3,333,330. Another clear example of the Metonetya numerical system is this instrument. This instrument predates what we currently call a ruler, a measuring tool that we use today. And I will highlight one section of this particular instrument. If we focus in on the bottom right corner, we can clearly distinguish these unit fractions written in Metonetia. The mouth above the numerical symbol indicates a numerator of 1. The first symbol on the right is unique. It is considered to represent 1/2. Next to that, we see a mouth over 3 strokes, which is 1/3. Then the mouth over 4 strokes, 1/4. The mouth over 5 strokes, 1/5, and so on, 1/6, all the way through 1/16. The Egyptians are known for their use of unit fractions to do calculations. The Wajet, or left eye of Heru, contains the fractions listed: 1/2, 1/4, 1/16, 1/8, 1/32, 1/64. If we add these parts of a fraction together, or these parts of the eye, we have 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64. The sum of those only gives us 63/64, which is not one whole eye. Symbolically, the Wajet was or is a magical eye, and it was the eye that replaced an eye that was damaged in a fight that Haru had with his uncle, Set Typhon. The eye was created, magically created, by the Necha Jehuti. There are other ways to symbolize that. Some in algebra, we can symbolize that as powers, negative powers of 2, or positive powers of 1/2. And either case or both cases would give us the same mathematical truth, that the sum of those parts are just one small piece short of a whole. Well, family, that's enough for one short introductory lesson to Meta Nature, the numerical system. The next unit on mathematics will focus on the process of doubling, again, using a method that was developed by our African ancestors. So please remember to subscribe and share, and please let me know if there's something that I should change or something that you see that doesn't make sense. Shem Hotep.